Our next few examples are going to start looking at the equations of lines. So in this example, we're going to be given the 2 points, -3, 4 and 2, 5, and we're asked to find the equation of a line containing those points, and we're going to express it in general form, which is the same as ax plus by is equal to c. So we're going to use point-slope form, but in order to do that, we first have to find the slope. So the slope is going to find the difference of the y-coordinates over the difference of the x-coordinates. So I'll have 5 minus 4 over 2 minus -3, which is going to be equivalent to 1 over 5. Right, so then I'm going to be able to use my point-slope formula. So I'll plug in my slope being 1/5, and it doesn't matter which of the 2 points I use, so use whatever one you would think would be easier. I'm just going to go ahead and use this second ordered pair. So I'm going to plug in 2 for my x1 and 5 for my y1. So I'll have y minus 5 is equal to 1/5 times the quantity of x minus 2. Now my next step is going to distribute through. So I'm going to get 1/5 x minus 2/5, but now here's where I need to keep in mind what form I'm trying to express my final answer in. So for general form, the key thing is that your variables are going to be on one side of your equation and your constants are going to be on the other. So if I get my variables to the same side, I'm going to have -1/5 x plus y is equal to, and then on this side I'm going to have -2/5 plus 25/5, which would be 23/5. So that's what I would get if I add those fractions together. Always try to work through the fractions on your own as well as using your calculator. It just really reinforces those skills. Now in some cases, in some textbooks, they are fine with leaving the standard form like this. You have your variables on one side and your constants on the other. But some textbooks in some situations may require the a, b, and c values in your general form to be whole numbers. So they don't like that there's fractions in here. So if that's the case, we can clear the fractions. This is a skill that you should be able to do. So if I find the least common denominator of all the fractions in the problem, which would be 5, if I multiply through by that, I would get -x plus 5y is equal to 23. So in some cases they consider this to be a better cleaned up version because I don't have fractions for my a, b, and c values. Alrighty then, so let's take a look at our next example. We're going to find the equation of a line perpendicular to the line y, or x minus 2y is equal to -5, and the line that we want will also contain the point 1, -2. And we're going to express the line in slope-intercept form, which is y is equal to mx plus b. Now, I will ultimately use the point-slope formula to find the equation of my line, but in order to do that, I have my point. Right? So I know I'm going to use the point 1, -2, but I don't have my slope. But I was told I'm perpendicular to this line. So if I can find the slope of this line, so to find its slope, let's go ahead and solve it for y. So I'm going to get the y variable by itself. So as opposed to x minus 2y is equal to -5, I'm going to have x plus 5 is equal to 2y, and then dividing everybody by 2, I get 1/2 x plus 5/2 is equal to y. Now in this case, what I'm looking for is the slope, which is going to be right here in front of my x variable. Since the slope of this line is equal to 1/2, so the slope of the perpendicular line is going to be the negative reciprocal of that. So I'm going to flip the fraction and flip the sign. So it's going to be -2 is the slope I want. So that's what I'm going to be able to bring in through here and put into my point-slope formula. Alright, so now that I have my slope in here, let's go ahead and clean this up. So I'm going to get y plus 2 is equal to -2x plus 2. And then subtracting 2 from both sides, I'll get y is equal to -2x, and this is in slope-intercept form because it's solved for the variable y. All right, and our next example, find the equation of a vertical line containing the point 4, -5. Now, if you just happen to remember that vertical lines will always have the form of x is equal to some number, you can come up with the equation of your line pretty easy. It's going to be x is equal to, and then just grab the x-coordinate of the point that you know has to be on your line, which is 4, and you can be done. Now, I tend to sometimes mess up like which ones are the vertical lines and horizontal lines, so creating a really quick graph can help you visualize what's going on. So the point 4, -5 is over here. So I know I'm going to want a vertical line, so I know what those look like, right? Those are going to be going straight up and down. So I want a line that goes straight up and down, and it contains this point 4, -5. Now, the equation of this line is going to be the extension of this tick mark along whatever axis this is. So first off, I can know that this axis is the x-axis. All right, so my equation is going to involve the x variable. And then my second question is, well, whose tick mark is this that I extended to form this line? And this tick mark is x is equal to 4. So that's just another way that you can come up with the equation of the line. All right, so another example. Find the slope in the y-intercept of the line x plus 2y is equal to 4, and then graph the line. Now, at this point in time, we can't read off the slope in the y-intercept because this is given to us in standard form, not in slope-intercept form. So let's go ahead and put it in slope-intercept form and solve it for the variable y. So to solve it for y, I'm going to get 2y is equal to -x plus 4, and then dividing through by 2, I'm going to get y is equal to -1/2 x plus 2. All right, so for this guy then, the slope is going to be the -1/2, and then the y-intercept as an ordered pair is going to be 0, 2. I can use this information then to graph my line. So 0, 2 would be right here on the y-axis, and then for the slope being -1/2, if I assign that negative to the numerator, I can read those directions as going down 1, right 2. Right, so from my given point I can go down 1, right 2, down 1, right 2, down 1, right 2, and I can keep repeating that. Or if I assign the negative to the denominator, I can read these directions as going up 1, left 2. So if I go up 1, left 2, up 1, left 2, up 1, left 2, I get a whole bunch more ordered pairs that I can go ahead and then connect to go ahead and form my line.